Bismillahirrahmanirrahim. FGI and protecting groups. Now we are going to discuss disconnection of simple ketones and disconnection of acids. Carboxylic acid. Disconnection of ketones and carboxylic acids. This is our lecture 10. Disconnection of simple ketone and acids. This is the ketone target molecule ketone carbonyl compounds by FGI. This is another way to disconnect. In the previous lecture, we have discussed to disconnect double bond as well as alcohol. Now we are going to do an aryl ketone. Now we are going to discuss ketone. The ketone by FGI reduction, it is converted into alcohol. Same manner. First, you will convert carbonyl into alcohol, then you will apply the same methods which you have applied before on alcohol. So first, by FGI reduction, carbonyl converted into alcohol, then alcohol will be disconnected by alkyl magnesium halide and carbonyl compound. The synthesis, in the synthesis, this is alkyl halide. In presence of magnesium and ether, it is converted into Grignard reagent. It react with carbonyl compound, then you will obtain alcohol. This is the secondary alcohol, and by oxidation, KMnO4, it is converted into ketone, which is your target molecule. Another example of uh, carbonyl compound, this is the analysis. This is the amide. And my amide, first you will hydrolyze, then in the hydrolysis, it is converted into amine and carboxylic acid. Amine and carboxylic acid. And this is the derivative of carboxylic acid, amine and carboxylic acid. Then carboxylic acid further disconnected into alkyl halide, magnesium and carbon dioxide. This is the carboxylation step. By FGI, this bromide is converted into alcoholic group. Further disconnection, again, the alcohol will be disconnected into alkyl magnesium halide and carbonyl compound. There are two or three approaches. You will disconnect carbonyl, you will convert carbonyl into alcohol by FGI, and you will disconnect alcohol by into alkyl magnesium halide and carbonyl compounds. The synthesis, this is the carbonyl compound and alkyl magnesium halide convert into alcohol. This is secondary alcohol, and conversion, the hydroxyl group is converted into bromide by using a strong halogenating agent phosphorus tribromide. This is the alkyl halide. Again, it is converted into alkyl magnesium halide, and the alkyl magnesium halide react with carbon dioxide. In result, you will get carboxylic acid. The carboxylic acid is converted into carboxylic acid is converted into acid chloride by using thionyl chloride, and the thionyl chloride react with amine. In result, you will get amide target molecule. Why are you converting acid chloride? Because carboxylic acid is less reactive, but is its derivative acid chloride is more reactive. So first you will convert into more reactive derivative, then it is converted into amide. Another example, this is your target molecule analysis. FGI, FGI double bond. This is the arising of double bond. This is the FGI, then double bond. You can convert into alcohol hydroxyl group. The another way, you can disconnect double bond by Wittig reaction. There are two options. First, you will convert single bond by FGI into double bond, and the double bond you can convert into Wittig reaction. This is the phosphorus helix Wittig reagent, and this is carbonyl compound. In the synthesis, this is alkyl halide react with triphenyl phosphine in presence of base. This is phosphorus helix. It react with carbonyl compound, then you will obtain double bond. And by the reduction of hydrogen platinum carbon with large catalyst, you will obtain single sigma bond. This is your target molecule. Another example, analysis of this target molecule, one is benzene ring, one is cyclohexane, both are connected by single covalent bond. This is the FGI conversion, double bond formation. This is FGI double bond formation. Then again FGI, OH, then disconnection of carbon-carbon bond by removal of alkyl magnesium halide and carbonyl compound. This cyclohexanone and aryl bromide and magnesium. In the synthesis, this is the bromobenzene react with magnesium and ether, react with carbonyl compound cyclohexanone. You will obtain this intermediate, and by the dehydration, you will obtain double bond. In the next step, reduction of double bond, you will obtain cyclohexane. So this is the another route. First, you carbonyl compound, the alcohol hydroxyl group is the key group. You can you can disconnect hydroxyl group easily. So the double, if the carbonyl is present, first you will convert carbonyl into alcohol hydroxyl group by FGI. Then you can apply number of routes. Similarly, the double bond, if the double bond is present, convert double bond into hydroxyl group by FGI, and you can convert double bond, you can disconnect double bond by Wittig reaction. The another one, if the single bond is present, first you will introduce the double bond by FGI, then double bond can be converted into hydroxyl group, and the double bond can be disconnected by Wittig reaction. So the one thing is related to another thing. This is your target molecule analysis. First, you will arise double bond by FGI. The double bond is here, and you will always prefer double bond in the substituted alkene. You will always prefer substituted alkene. Okay, the substituted alkene you will prefer because it is more stable. And by the FGI, the double bond is converted into hydroxyl group. And the hydroxyl group you can disconnect by alkyl magnesium halide, isopropyl magnesium bromide, and carbonyl compound. And this is the Federcraft acylation, benzene ring, and carbonyl compound, acyl chloride. In the synthesis, this is the compound benzene ring. Two methyls are attached in the benzene ring. Steric hindrance. This is this side acyl by the acyl chloride. The steric hindrance, this methyl and this methyl. This side has steric hindrance because this position is active. This position is also active, and this position is also active because the methyl are ortho para directing group. So this is the para position with respect to this methyl and ortho position with respect to this methyl. And this is also common for both ortho position for both but due to steric hindrance, because this position in between two methyl group, so this position is more active with the all positions. Acyl chloride react, and the substitution will be occur at this position. This is the acylation, Friedrich-Krafft acylation of benzene ring. Then isopropyl magnesium bromide react with carbonyl compounds, then you will obtain alcohol. This is a tertiary alcohol. The tertiary alcohol is readily dehydrated. In presence of phosphoric acid, it is readily dehydrated. The double bond is obtained. Then you can reduce double bond into single bond, and you can obtain your target molecule. Analysis of another compound, two cyclohexane ring, they are attached to each other by a single covalent bond. First, you will apply FGI, the double bond will be introduced. In the second step, you will introduce hydroxyl group by FGI. Then you can disconnect OH by alkyl magnesium bromide and carbonyl compounds. In the synthesis, alkyl halide react with magnesium and in presence of diethyl ether as a solvent. Then you and it will obtain alkyl magnesium halide, which is the Grignard reagent, react with carbonyl compound. Then you will obtain this is tertiary alcohol. This is the tertiary alcohol. By the tertiary alcohol is readily dehydrated in presence of phosphoric acid, the double bond is obtained, and you can reduce double bond into single covalent bond by using Lindlar's catalyst hydrogen cardium carbon. It is converted into your target molecule. So these are the number of examples in which you can disconnect carbonyl compound as well as hydroxyl group and double bond. And the compound, there is no possibility, this is the compound, there is no functional group. What is the possibility to disconnect? So you can introduce the functional group here by FGI double bond. So you can easily, this double bond can be reduced into single covalent bond. So if you have no uh, functional group, uh, how you will disconnect, how will you disconnect the molecule? You can introduce the double bond, then double bond can be converted into hydroxyl group, then hydroxyl group can be converted into ketonic group. So it means any molecule has possibility to disconnect. If you will apply the disconnection approach, then you can synthesize this compound. Okay. Gee, any question related to this? जी कोई सवाल?
No, sir. But sir,
क्या रीजन है कि डबल बॉन्ड बनेगा तो कटेगा, वैसे सिंगल बॉन्ड नहीं टूट सकता? इसकी रीजन क्या हो सकती है सर?
कोई रीजन नहीं है। सिंगल बॉन्ड को कैसे तोड़ेंगे और कैसे बनाएंगे? रीजन कोई भी नहीं है। हम ये देखते हैं कि क्या चीज फिजिबल है। आप सिंगल बॉन्ड को ब्रेक कर दें, ठीक है ना, आपने ब्रेक कर दिया तो दोबारा कैसे मिलाएंगे? फिजिबिलिटी देखी जाती है। एक रिंग है, ऑलरेडी रिंग मौजूद है, बहुत अच्छा है। आप उसको ब्रेक करेंगे और फिर उसको बनाएंगे। बिल्कुल हर चीज, जैसे आपने कहा ना सिंथेसिस कई तरीके से बन भी सकता है, वो 10 स्टेप लेगा। ये आसान है कि उसको कम स्टेप में कर दिया जाए, हर चीज बन जाएगी। लेकिन बनाते बनाते आपको 10 स्टेप लग गए तो फायदा नहीं ना। आसान ये है कि उसको आपने चंद स्टेप में कर लिया।
ठीक है, थैंक यू सर।
ठीक है जी, खत्म करते हैं यहाँ तक। अल्लाह हाफिज।